Assalamualaikum and hello everyone. Welcome to the video where we will discuss past year question for the year of 2019-2020. In this video, we will discuss question 5 involving chapter 6 chemical equilibrium. Question A, sulfur trioxide gas decomposed to sulfur dioxide and oxygen gas according to the following equation. 2SO3 gas in equilibrium with 2SO2 gas plus O2 gas. Okay, when 1 mole of SO3 is placed into a 2-liter vessel and heated to 344 Kelvin, the system achieves equilibrium and 0.6 mole of SO3 gas is remain. Okay, 1 Roman, calculate the concentration of each gas at equilibrium. Okay, so based on the information given, what we have is our mole. Okay, so the question wants it to be concentration. So first, what I would like to do is I want to label, okay, what is the information given in terms of molarity. Okay, so molarity, the formula is number of mole divided by volume. The volume is already given in the question. So now we know that for this one, mole ni, we're going to divide by 2. The same goes here, 0.6 ni pun we divide by 2. So now we know that SO3 gas, okay, in equilibrium is 0.3 molar. But then the question asks, calculate the concentration of each gas at equilibrium. So the question only know about SO3. So now we have to find what is the equilibrium of SO2 and O2 at equilibrium. So how do we find out the equilibrium? That's why we have to do the ICE table. So again, ICE table stands for initial, change and equilibrium. Make sure you write down the unit as well. So what we have here is concentration. So I'm going to write down M. Okay, so why did I change it into concentration? Because the question did ask for the concentration. So it will be easier for me just to write down at the start. Okay, so for the ICE table, right now what we're going to find out is actually we want this one, equilibrium of SO2 and O2. Okay, but then initial, okay, we have to fill up the table. Okay, so initial for our SO3 is given in the question 0.5. Okay, for our product, there's none because product at the start it is 0 lah. Changes for our reactant must be minus our product plus. Okay, so here will be minus 2x plus 2x. Here is plus x. Okay, x is our unknown. We do not know the changes, but we can know that if for our reactant, the concentration will decrease. For the product, it will increase lah. Lagipun the 0, it will be increasing lah. Okay, for the number at the front here, based on the equation. 2 here, this one 1. Okay, for make sure that the equation is balanced lah, and then we have to write down. So equilibrium is when we add up our initial and change. So this will be our equilibrium. Okay, so again the question asks the concentration at equilibrium for all the species. Okay, we have known that at equilibrium we have 0.3 molar of SO3. So we know that the equilibrium for SO3 is 0.6. And then based on the ICE table, we know that 0.5 minus 2s will become 0.6 molar. Okay, then we can use this information, okay, to find x. Okay, so again, I know that SO3 equilibrium is equal to 0.6 molar. Okay, now I'm going to find my x here. So SO3 equilibrium. So what I mentioned here lah, equilibrium. This one. Okay, make sure this one is not 2x. This one is plus x only kan. So this one must be x lah. 2x ni yang ni je. This one will be x. Okay, so we can find the equilibrium of SO2 and equilibrium of O2. Then you know that concentration of SO2 equilibrium will become 0.2 because multiplied by 2 here. While concentration of O2 will be 0.1 molar. Okay, so again the question asks calculate the concentration of each gas. So we have to mention lah for each one of the gas, even though this question already based on the question itself it have given us the equilibrium concentration of SO3. We're just gonna write it down. Okay, that's for question 1 Roman. Question 2 Roman, calculate the equilibrium constant at 344 Kelvin. Okay, so first, before we're going to calculate the Kc, we're going to write down what is the Kc itself. Kc stands for the concentration. Okay, concentration again only for gas and aqueous state. Since all the species here is gas, so we're going to include all. It will be product over reactant. Okay, make sure if you have stoichiometry at the front, it will be to the power of. Okay, again for the Kc, Kc stands for equilibrium constant. Okay, equilibrium constant, C for concentration. So for this value, this one all must be the equilibrium lah. And all the value in equilibrium we have found out from the previous question. This one. Okay, make sure you substitute the correct one. And you will get the value to be 0.044. Okay, so for question A ni, okay, you have to do, again, why we have to do the ice table, because the question asks for the equilibrium. We only know about one species. So for the other species, you have to do the ice table. That's the solution for question A. Question B, phosphorus pentachloride, PCl5, is left in the sealed container to establish equilibrium. So for the equation is PCl5 gas in equilibrium with PCl3 solid plus Cl2 gas. Okay, question 1 Roman, explain the effect of lowering temperature on the equilibrium constant Kp on the system. So if the question did ask about effect of lowering temperature, or lowering concentration, or lowering pressure and such, again this is goes back to our de Chatelier principle. Okay, de Chatelier principle mentioned that, okay, for a system in equilibrium, if there are some disturbance, in this case disturbance kita is lowering temperature, okay, the reaction ataupun the system will try to counter back, okay, the disturbance by try to reducing it. Okay, so now we're talking about lowering temperature. So when we're talking about lowering temperature, for temperature first, what we need to know is about our delta H. For a given reaction, if delta H is equal to positive, it means that the reaction is endothermic and heat is absorbed. While if the delta H is negative, so it means that the reaction is exothermic and the heat is released. Okay, so why is this important? So that you know that when we mention about heat absorbed, heat will be on the reactant side, while if heat is released, it will be on our product side. So in this case, our reaction delta H is equal to negative value. So if it's a negative value, so it means exothermic, heat release, the heat will be on the product side. Okay, now we know that the heat is on the product side. Okay, now we can mention, or we can do the analogy. When we're talking about temperature, I like to use the analogy lah. If heat, so it means that this is the hot place. If there's no heat, it will be the cool one. Okay, so kalau tempat yang panas ni, kita kata ni Labuan. Kalau tempat yang sejuk ni, kita kata Kundasang lah. So once we have known the hot place and the cold place, kita senang nak jawab soalan. So question 1, explain the effect of lowering temperature. So again, Le Chatelier mentioned that it will counter back. So first point kita, we have to mention that the system will try to counter back, dia akan try to increase the temperature itself. So when it try to increase temperature, so that's why lah kamu kena, you have to know which one is the hot place, which one is the cold one. So increase temperature means that kita nak pergi tempat yang panas, the hot one. In this case, tempat panas kita, Labuan, which is on the right side. Okay, so you can't write down shift to the right je. So what does it mean by shift to the right tu? I know it will be moved to the right, tapi apa yang shift to the right? So we have to mention that the equilibrium position shift to the right. So once the equilibrium position shift to the right, so what does it mean is that PCl5 will form our PCl3 and Cl2. Okay, so in this case, what does it mean? PCl5 will decrease while our PCl3 and Cl2 will increase. Okay, but then again, when we're talking about the decrease or increase, this is about concentration. Okay, for concentration, it is only for our gas and aqueous. Okay, for our solid and liquid, the concentration remain constant. So that's why we do not mention increase atau decrease lah. Okay, so we have to mention that PCl5 ni akan decrease, so shift to the right. Okay, PCl3 again the solid, so it's not included in the concentration. So Cl2, our product will increase. So we have to mention lah. So the effect there first is the concentration, which one will decrease, which one will increase. So that is, if the question asks to explain the effect, then this will be the point lah. First you have to mention the counter back. You will shift to where? The equilibrium position shift to the right of the left. What happened to the concentration lah? Okay, but then specifically for this question asks the effect of lowering temperature on Kp. Okay, so go back to this equation. So what is the Kp for this equation itself? Okay. So Kp is the pressure of Cl2 divided by pressure of PCl5. So for the pressure, again, this is the partial pressure lah. We have to write it down macam ni. It won't be square bracket. Square bracket ni means concentration. This one about pressure. Pressure the regular bracket, the round bracket. Okay. But then, okay, what will happen to the Kp? So dia kata dekat sini, concentration PCl5 decrease while the concentration of Cl2 increase. So what happens is that our Kp will increase. So why is it decreased? Okay, so for example, originally I have assumed, I'm going to assume my PCl2 is 1, my my pressure of PCl5 is equal to 1 as well. Okay, I'm just going to assume this one lah. Okay, so for example, originally dia 1. Okay, tapi but then, okay, kita assume concentration and the Cl2, apa ni, the concentration is directly proportional to the. Okay, for example, originally assume that our pressure dengan PCl5 originally only 1. Tapi here it mentioned that it will decrease, PCl5 decrease. For example, I'm going to write down here is 0.5. Cl2 here, for example, increase, I'm going to write down 2. Okay, so if we divide this value, we can see that the value will be, your Kp will be equal to 4. Originally, if not, it will become 1 over 1. So, become 1 lah. Okay, so why does it increase? Sebab our numerator have a bigger value than our denominator. Okay, so if I put down the value, then you can see it clearly lah. Tapi since the question asks only about the effect of Kp, does not give any value anything, so Kp increase. But then before you write down the effect of Kp, you have to mention lah. So what will happen to the system? Okay, what does what it will try to counter back, dia punya shift ke mana, what happened to the concentration. Okay, so that's for question 1. Okay, question 2 Roman, explain the effect of adding argon at constant volume on the equilibrium position. Okay, so again for our Chatelier, actually we have 3 main factors, which is concentration, temperature and pressure. Okay, but then the question here mentioned about adding argon. Argon is our inert gas. So there are actually about the Chatelier, we'll talk about the inert gas as well. So for the inert gas here, we have 2 cases. It's either constant pressure or constant volume. Usually we're not just going to add inert gas lah. It will be specified to the constant pressure or constant volume. Okay, so for the constant pressure, it acts as if we decrease the pressure itself. Okay, so why? I'm just gonna include the link in the description. Okay, so for you to see, okay, why does constant P means that we have decreasing pressure. Okay, but for the constant volume, there's no effect lah. We will not decrease the pressure or the partial pressure of each of the gas. Okay, so back to the question, they asked to explain the effect of adding argon at constant volume. So for the constant volume, there's no effect. Okay, there's no changes anything. So how to explain it? Okay, so since it does not have any effect, so we will just mention there's no here lah. The system will try to increase balik ke apa. The equilibrium position shift pun tak ada. Okay. So but then what will happen to the equilibrium position? So the equilibrium position will not change. It will not shift anything because here it has no effect. Okay, but then we have to mention why adding inert gas at constant volume has no effect. What happens is that the partial pressure of each gas does not change at constant volume. Okay, so for the reason why, again, I'm going to link the video in this description so you can refer back lah. Okay, so this one, because you have to explain, not only you're not gonna mention that it does not change, you have to explain why. Okay, so if it doesn't have any changes, then these are the 3 points that you have to include lah. The counter back, the equilibrium position shift, and what happened to the concentration. But if does not, you have to mention does not too and why. Okay, so that is all for the solution for the video of 2019-2020.